Let's talk measures of central tendency. So measures of central tendency is about where either the middle of a distribution of a single variable is or the most common. So the mode is the one that's the most common value of the distribution. So it's the value in a distribution of a single variable that is happening the most often in your sample. And I love the little bears repeating, so I just put that in. So you can have one mode, you can have more than one, or you can actually have no mode, which is really unlikely. Having no mode is you don't see that very often, but no mode means that it's equal probable, which essentially is that every value of your distribution there's the same number of people in each one. That doesn't happen very often though, but that means that literally each value is equally likely to happen, so that's why we call it equal probable. Or you can have one mode, so meaning unimodal, so there's one that is the most common value, or you can have more than one mode. So you can have it bimodal if you have two modes, or you can have trimodal if you have three, or multimodal. But the mode is the only measure of central tendency that's available for a nominal level variable. So it's definitely appropriate when you have a nominal level variable. It's the only thing you can use with a nominal level variable. But it's also useful if you just need to know the most likely value, even if it's a variable where there's, you can do a whole lot with it. It's a quantitative variable, but you still want to know, well, which one is happening the most. Two potential problems. If you have no mode, again, that doesn't happen all that often, but if you don't, then that doesn't really tell you very much, except that everything is equally likely to occur. But the more useful, more sort of common problem is that the mode might actually fall far from where the main clustering is. So for example, if there's a lot of zeros for a variable, but the real clustering is happening around some other number, there might be more values that the cases are split between, but there's actually more cases in that cluster. So for example, if you have something like, you're asking a criminal population, how many previous convictions do you have? A lot might be 0, but the main area of interest could be the clustering that's happening between like 1 to 4, for example, where between those, 1, 2, 3, and 4, that's where the majority of the sample is, but the actual single mode is 0. So that can happen, which is why if you don't have to only rely on the mode, you use other measures as well. So another measure of central tendency is the median. And so the median is just the point at which you can divide the distribution in half. It is what's called the 50th percentile. So this you can't use with nominal level variables. You have to have something that you can split in half. So to determine the median then, you want to first rank order the values from lowest to highest. So you want to make sure that they're in that order, because if they're just in a random order, your median won't mean anything. So if you just have a list of values, make sure you put them in order from lowest to highest. Then you kind of have to do different things if you have a odd number of scores or an even number of scores. So an even number of scores, you would actually have to, because if your position would be between two numbers. So if, for example, you've got like 6 measures, so 6 people in your sample, and you measured them on this variable, let's stick with something easy and say age, then you're going to have 3 on one side and 3 on the other side of where that actual midpoint is. So the midpoint isn't going to fall on one of your values, it's actually going to fall in between 2 of your values. So if you have an even number of scores, then you actually have to find the positions of, so if we have 6 values, then our middle is going to be right, so there's 3 on either side. So our position we need to find would actually be what number is in the position 3 and 4, because then our median is actually right in the middle of that. So what you do then is, and typically you have more than 6 positions. So if you need to find where that position is, the first position is going to be n, which is the total number of your cases, over 2. So 6 would be 6 over 2. So it's our third position. And then the position number 2, you add 2 to the total n. So if we have 6 values, it would become 8 divided by 2. So it's position 4. So that gives us our positions at 3 and 4. And so then we would add the scores in those positions and divide by 2. So Let me give you an example. So we're going to bring up my little paint here so that you can see sort of what we would do here. So let's say, for example, that let's use a pencil here instead. So our numbers are 1, 2, 4, 7, 10, and 11. So I'll put commas here so we can tell what these. So we're going with 6 just to sort of keep it simple for now, but so that you can see. So we've got our n over 2. So that n is 6 over 2, so we know that's 3. And then n plus 2, so that's 6 plus 2 is 8 over 2. So then that's 4. So these are our positions. So we know that our positions are position 3 and position 4. Now, after you do that, we are adding the scores, not the positions. So you don't add 3 and 4 and say that your median is 3.5. You have to then, once you find the positions, you add the values that are at those positions. So in this case, we would add 4 and 7. So that gives us 11. And then what you're going to do is then you divide that by 2. So 11 divided by 2 gives us 5.5, 0.5. So our median then is 5.5. And it falls right in the middle here. And it's 5.5. And I know that's kind of messy, but that sort of tells you, so don't mix up the position numbers with the actual median value, because those position numbers just tell you where to look to find the right numbers, and then you have to figure out what's halfway between those two numbers to see where the exact middle of your distribution is. Okay. So that would be if we have an even number of values. But if we have an odd number of values, then we just find one position. And so it's n plus 1 over 2. So let's just do another example here. All right, so let's just erase all of this. Okay. So if we have, let's say we have the same as our numbers that we had before. We got 1, 2, 4, 7, but now we just have 5. So we took off that 11. So now we just have 5. Now you can see that, and like you can probably easily see where the middle is, and notice that they are in order from lowest to highest. But just to sort of show you how it works, so we would do, it's now n plus 1 over 2. So we have 1, 2, 3, 4, 5. So this would be 5 plus 1 over 2, which gives us 6 over 2, which is 3. So again, this is our position. So we go 1, 2, 3. We have found the position. And that now tells us, well, that's where you're going to find your median. And now the median is the value that's at that position. So the actual median is 4. So don't mistake the position number with the value number. So it's a little easier if you have an odd number of scores, because you only have to find the single position. You don't have to find the in between two positions. But that's just kind of be however many data points you have. So the median is not appropriate to use if you have nominal level variables. Why? Because you can't put nominal level variables in order from lowest to highest. If they are nominal, by definition, they don't have an order, so you can't put them in order. So it doesn't make sense to use median to describe a nominal level variable. Then we have the mean, which is probably what you think of when you hear average, which all of these mean, median, and mode are different types of averages. But mean is probably the one you've seen before. It's the arithmetic average of all the scores in a distribution. And so to determine the mean, you have probably done this lots of times before, whether or not you've actually seen or thought of it in like an equation. Although equation is a stretch. When all we're doing, you're adding up all the values of all the cases. So this has nothing to do with positions anymore for this one. This is just the value of all the cases and then dividing by the number of cases that you have. And so this is only appropriate for interval or ratio level variables, or sometimes ordinal measures can be treated as interval, but that's kind of rare. So the general kind of rule is that if you have an interval or ratio level variable, then you can use the mean. But remember, it may be appropriate to use both the median and the mean if you have interval or ratio level variables, or neither, depending on what your variable looks like and what your distribution looks like, especially if you have extreme values, because the mean is very sensitive to extreme values. So if you have a lot of your sample clusters in this one area, and then you have like a crazy high or crazy low value, it's going to pull that mean in whichever direction that extreme value is. So that's why it's sometimes, if you have extreme values, you can present the mean and the median, because the median is not sensitive to extreme values because it just counts the number of cases on either side. It doesn't matter where those cases are. So the mean is not as sensitive to extreme values. The mean is. The median, so the median can tell you something different from the mean. But if you have a normal distribution, if you have a nice, beautiful bell curve, your mean, your median, and your mode will all be the same number. So think about that.